everybody. Welcome back. I hope you had a good and interesting break with lots of fabulous discussions. We at EPIC are very pleased to be hosting this conference, and many of us here use a lot of data in our models. And so for that, we use all kinds of different data and a whole variety of models. We use statistical models and dynamical models, and we put into that both disease data and kind of background data about how animals might move about, and environmental data. So we are extremely pleased to be welcoming Tom Wilkinson, our Chief Data Science Officer for the Scottish Government, to give us a keynote on AI opportunities and challenges, a responsible and ethical approach. So Tom is the Chief Data Science Officer, and he's got extensive hands-on experience working across all areas of data science, data analytics, data architecture, software development, and data engineering. He's got a lot of experience across various different UK government departments and spent several years developing and improving organisations' use of data and operational decisions. So with that, if you would please welcome Tom. Thank you.
Thank you very much, Sam, and that sounds like the microphone's working. I will expand on what Sam was saying, that I'm Chief Data Officer for Scottish Government, which means that more than just AI, and the AI strategy is part of my remit, is also the general reuse of data across the public sector. I think from a management of disease perspective, the intersection of those two things becomes quite interesting, where we're talking about how to actually bring into practice the research that's done through the community around EPIC, and bridge that to operational decision making. You get into the world of data. So today I'll be talking both about AI specifically and data more generally. So starting with that theme of data, a lot of the work that we do day to day in Scottish Government around data is precisely about allowing data from different places to be used together. And some of the most fundamental elements of that are just getting organizations on the same page. So we've been doing quite a bit recently in terms of establishing a common vision for data across public sector organizations, but drawing on inputs from private sector and third sector as well. The vision itself that we came up with through that work is pretty uncontroversial and pretty non-specific to EPIC. I'm reading animal health somewhere between people and planet here, or probably encompassing both of those. But most importantly, alongside that vision that we have been developing for data, there are a number of much more specific ambitions that start to help organizations across the public sector as they develop strategies around their data maturity to get themselves on the same page, to speak the same language, to say consistent things to their leadership in order to get the funding, to mobilize the resources, to help them do more with data. And that starts to become very important when we're hoping to combine some of the knowledge that comes through research with a dependence on empirical evidence and needing a grounding in what's going on in the real world with operational data that can actually identify where it's relevant. Some of the things that we're doing in practice on the side of data to, again, help bring that data together from different places. So first of all, making it findable, accessible, interoperable, and reusable. The acronym FAIR, which I think originated in research. And we are doing that through a number of technical instruments alongside some of that same community building that we're using for the vision work that I just described. Some of those technical solutions, like data catalogs that can be shared or federated across public organizations, help make sure that there's an understanding of what data is where. For example, the kind of agricultural data that might help with the application of the research coming from this network. But we're also working on tools to help with establishing the public acceptability of particular uses of data, or indeed AI, and I'll come around later on to how that plays into our ideas for understanding the ethicality of AI. And crucially as well, tools for identifying data sets in the first place that could be produced as open data, or indeed which could be better described and served up for combination with other materials. And that becomes quite relevant from a research perspective, along with the data cataloging, because it offers the prospect of bringing data from the public sector into the safe haven in order to do practical research on it. And that too starts to offer a path for going from research to operationalization of some of the insights coming from epidemiological research, through understanding how the data that's held in administrative systems in the public sector might be combined with the kind of analytical approaches and external data sources which are the basis of the work done by EPIC. Moving on then to AI, which is the subject of the day, and where we've already seen some really exciting stuff from Christos. It's really important whenever I talk about AI across the public sector for me to first manage the language here, where we've all been hearing a lot about AI in the popular press over the last couple of years, and it's often conflating a whole bunch of different things and focusing very much on a narrow area of what conventionally might be called AI. AI itself is a pretty nebulous term. I've heard it used to describe all kinds of things, especially when people are trying to sell me stuff. Suddenly everything is AI, including the most basic web scraping. But broadly speaking, AI researchers divide things up into two general camps. One being what I might call machine learning, which tends to be about the statistical recognition of correlation of patterns between different bits of data. Sometimes very, very large volumes of data or very complicated data like images or sound. And that side of AI is the focus of most recent attention. There's another face of AI as well, where we're trying to get machines to replicate the kind of logical thinking that people do, or the kind of causal understanding of the world that we might take for granted, but and we're not necessarily great at ourselves, but is often going on behind the scenes in our decision-making day to day. Now, that kind of AI was the subject of the last AI boom, which the majority of people in this room may not have had to deal with. But it's worth emphasizing, with all of the current excitement about AI, much of it justified in terms of the potential real-world impacts, it is the nature of AI, like many other technologies, that we get these brief glimpses into the research, which suggest a radical change of possibilities, where actually behind the scenes there's been a much more continual advancement. I'm sure as researchers you'll all be aware of issues with public access to and understanding of research. Within that machine learning box, there are some exciting applications like machine vision that Christos gave us some really compelling demonstrations of today, and where we see a lot of the most practical applications, which I'll talk about in a second. And then we also have various other boxes, one of which is the generative AI, and most specifically the large language models like ChatGPT, which have garnered the most attention recently. And again, I'm doing this scene setting to help people appreciate that when I talk about AI, I might be talking about a lot of things besides what's most topical in the news. But that's not to deny the significance of what we're seeing in the news. To help, again, ground AI in the realities of how it's being used already in the public sector, we're seeing, for example, machine learning in that general sense of pattern recognition already proven in trials by the NHS, for example, in Glasgow and Clyde, to help with the prediction of pulmonary disease through the analysis of case information. We're also seeing its use to help with the maintenance of transport infrastructure by Transport Scotland, for example, comparing climatic and weather data with sensor data on bridges. Machine vision, where we're applying those same general principles of looking for statistical relationships between certain things in the data and certain other things, potentially categories that we've specified for data. We have started to see applications in healthcare again, maybe quite famously, where historically a small pool of experts would be needed to analyze medical images, which introduces significant bottlenecks and time constraints in terms of how quickly the backlogs of radiography and other imaging sources can be processed. We've started to see machine learning demonstrate real value in not substituting for those experts, again, because of that difference between spotting patterns and understanding the causal mechanisms behind them, but potentially speeding up triage and the processing, the workflows there to help make sure that the medical experts are directing their time as effectively as possible, given the limited pool of those experts. And perhaps relevant to animal disease is some of the applications of AI we see already from Marine Scotland, where whether it's in catch nets or live in the water or on conveyor belts, there are various applications of machine vision to identify different species of marine wildlife. Again, that has all kinds of applications for understanding marine ecosystems, but I suspect too for potentially understanding the disease risks. And then coming around to Gen AI and large language models, our division in Scottish Government were early to employ some of these technologies. Through Scottish Government's CivTech commercial challenge mechanism, which I'll come back to in a little bit, we very early on issued a challenge around improving the handling of calls coming into Citizens Advice Scotland, using a number of different forms of AI, both to triage the calls coming in and to then help with both the sound and text sort of communication of particularly people with disabilities trying to access those services. But for all those exciting applications of AI, and in particular large language models, it's worth me trying to manage some of the hype as well here, and certainly some of the unhelpful misrepresentations of the technology that we see, even from, but maybe unsurprisingly, from the companies who are trying to sell it to people. There is a lot of speculation, including by senior tech leaders, about how soon AI will be substituting fully for people in various things. But the story that comes from the systematic research out there tends to be one of humans and AI tools working very effectively as a team, rather than any AI system being a straight-up substitute for a person in everything that a person might do in a particular role. To cite some of that systematic evidence, we saw a study of Microsoft and Accenture programmers that demonstrated that for senior programmers, there didn't seem to be much productivity gain at all, insofar as we can measure productivity in their outputs as coders. For junior programmers, we do see some increase in the output of code that they produce, but we also, for Accenture at least, saw a corresponding decrease in the quality of that, the number of failures of the systems that they'd put together. Now, the story in the round there is not one that dismisses the value of AI supporting computer programmers. Generally, we see that there is a massive uptake, and the anecdotal wisdom is that these represent useful tools. But what had early on in the recent excitement around large language models seemed like the most obvious and valuable application, which was to help people with computer programming, that doesn't necessarily bear out statistically as a massive change to their productivity. We've also seen counteracting some of the suggestions that large language models are approaching sort of PhD level mathematical capabilities. We've seen research from none other than Apple that helps to demonstrate that if you tweak the maths problems you're giving to large language models away from the kind of thing that appears routinely in tests, they can fail quite dramatically. And indeed, that's borne out by studies we see in cognitive psychology, testing large language models not in the way that the AI researchers test them, but in the way we might test a human. We see them perform very, very well, better than people in some respects, and yet completely unable to do things like causal reasoning or to deal with subtle departures from the kind of classic vignettes that psychology experiments tend to pose. All of which shouldn't be too surprising when we recognize that AI tools are essentially pattern matching. They've been fed an inordinate, incomprehensible amount of data that no human could process, and they've looked for things that they can copy from that and reproduce. So although in our day-to-day browsing of the internet, we might not read 1,000 maths exams and 10,000 psychology problems that have been posed, these algorithms have gone through all of that data, and they have found the repeated patterns that, much like when someone's practicing for exams, to just answer the typical questions that come up, large language models are very, very good at that. And it doesn't mean that they're good at the underlying expert thinking that those exams are designed to test for by proxy. And then last of all on this point, even for some of those benchmarks that the AI researchers have set themselves, those criteria that they want to see performance gains against, in the last 6 months, we've started to hear rumors of the latest models not necessarily performing against those as expected. So what had been described for the last couple of years as an exponential improvement that meant that AI was only going to get more powerful and therefore could only conceivably surpass humans in sort of a 5-year period or something like that. As anyone with maths experience in the room will know, an exponential curve looks exactly like a sigmoid curve up until the point that it starts to sort of turn around and fade off. I'd imagine that's something that comes up in epidemiology as well. So to get into a bit more why there's that distinction, and And harking back to the slide I showed you with those two schools of AI, it largely comes down to that disconnect between the ability to get computers to match patterns and predict those, and the ability to get computers to think logically or causally. So there are generally two quite separate schools of AI there with some minor overlaps. And what we've seen is incredible gains in the performance of the AI tools that are doing what you might call fast thinking in behavioral psychology, which is to say that reflexive, having practiced an exam lots of times before, ability to answer the questions without necessarily understanding the underlying theory. So large language models are fantastic at that. What we've not seen is an improvement, a commensurate improvement in the other branch of AI, and what we've not seen is really effective links between those two approaches to AI. And that's why I say those claims about AI matching human capabilities aren't really well founded right now, and what we're waiting on there is an unknowable technological leap rather than an inevitable improvement of performance. Now, what that also means, unfortunately, is it's quite hard to judge what the impact is going to be long-term of large language models and generative AI for a lot of the things that people do, because we don't have a systematic audit of how much day-to-day we use that fast thinking compared to the slow, systematic, logical, or causal thinking that we otherwise do. It's just not something we've conventionally done to sit down and ask researchers or doctors or secretaries at what point they're acting reflexively and at what point they are considered and logical in what they're doing. And so essentially that means that for us to realize the potential benefits of large language models, I think we're in fact talking about quite extensive research, the kind of thing we would call in digital development, user-centered design, to unpick which aspects of things people are doing day to day, call on those different mental faculties, how much we switch between those different tasks, and whether we can conveniently slip a large language model tool in between. Now, before I get onto some of the more hopeful stuff, it's also worth, in the context of ethics, talking about the implications for generative AI around intellectual property. And similarly in a research space around the ethics of ownership of research. So crucially, because generative AI and large language models in particular have been trained up on a vast amount of data beyond what any one person could process, could compare. And because they've essentially compressed that, boiled it down into some simple rules that can be used to generally reproduce what was in that data, what we can't do is reverse that process to understand precisely what data they've been trained on, or indeed, when we get a particular result out of them, what bits of its training data led to that particular output. So we have major problems with understanding both whether a particular bit of intellectual property was fed into a training of an algorithm in the first place, but crucially also which we can attribute a particular output to. So if, for example, in the image space, we get a particular image generated by an AI model, it's very hard for us to decisively say, well, this image drew on these particular sources, and therefore those owners of those original pieces of intellectual property should be reimbursed in some way for that. Similarly, if you're talking about plagiarism in a research context, it could be very, very hard when you're talking about a model that's been trained on a number of papers that goes well beyond anything that an academic could read in their lifetime, for you to decisively identify which ideas from where have been fed into that. And anecdotally, there are major problems for publishing through the proliferation of AI-generated research, some of which may be very convincing, some of which may even be valuable, as I'll get into in a second, but which is very, very hard to trace back to the sources. It's worth me just pointing out quickly here that although when people talk about these problems with AI around provenance, around intellectual property and where the data has come from in the first place, people often look to AI for the solutions, but it's worth pointing out that there are other fields of technology which help here, cryptography in particular. And lastly, all of this intellectual property stuff obviously has a significant legal element to it as well, and because of the arcane nature of this technology, that will inevitably be quite slow to catch up and set clear boundaries on what is right or not. So where I have used images from Gen AI throughout these slides, I need to be careful to stop using them at some point in the future when the precedent becomes clearer. Okay, so I've poured some cold water there on AI, but now it's also worth me emphasizing just how incredible AI in general is. So particularly in the broader sense, when we're talking about some of the technology that sits underneath Gen AI, but engineered in a much more careful way for a particular task. Many of you here may be aware of the AlphaFold work done by DeepMind, which contributed to a Nobel Prize. Now, crucially, the kind of task we're talking about there, protein folding, is one where we understand or have a good model for the basic mechanics at the level of individual proteins, but the task then of exploring all of the possible molecules that can arise from that and how they shape themselves through the forces between those molecules or those atoms, it is way beyond what an individual can analyze, way beyond sort of theory, and beyond computers just approaching through brute force. And what AlphaFold has done and rapidly accelerated beyond what humans had been able to do through our own innate pattern finding abilities was pick up on some of the, I guess, rules of thumb that help predict what a particular sequence of amino acids might lead to in terms of overall protein structures. And alongside the work on AlphaFold, we're also seeing generative AI now used to design proteins which have not been seen before, which obviously promises all kinds of potential technological advancements in the future. Alongside that work in proteins and genetics as well, we've also seen similar approaches applied in material science. Again, the same sort of general scenario of a situation where we understand the constituent parts pretty well, but it's their combination that gets very hard for humans to develop intuitions for, or for us to run enough computer simulations to understand all of the possibilities and pick up on the common themes. And again, we're seeing incredible progress there. And in terms of that human-computer team, we're again seeing that it's the best researchers, according to certain measures, who gain the most from the tool. So rather than it being something that's a substitute for their ability as researchers, it's actually a catalyst for that, where we see the gains. We've also seen examples of Gen AI, so large language models themselves, contributing to research. I think you might intuitively think of it as interpolating between different bits of research. You think of the sort of vast interdisciplinary body of knowledge that exists out there. It's clearly beyond one person to bridge all of the different specialist topics within one field, let alone across different disciplines, which might be talking about similar things mathematically with very different language. Now, large language models, by dint of being able to process so much information and find patterns, are well placed to pick up on some of those connections between disparate research that realistically people can't. And so again, there's the prospect of researchers being helped by AI to direct themselves to the problems where their human abilities can then add the most value. And all of this with the prospect of those human AI teams doing amazing things together starts to raise questions around ethics. Scotland, as a nation, was very progressive on AI. We had an AI strategy back in 2021, before the UK and most other countries. And we were one of the first countries to launch an AI register, so a public record of where AI is being used in the public sector, and to make that mandatory this year. That register also helps us start to systematically manage the risks around the introduction of AI. So where we might see AI tools proven in the research world, looking to be implemented in practice for decision-making around public health, we would expect those processes to apply in helping us to understand whether that is an appropriate use of AI. Now, we have also started to develop processes to get into that ethicality. But within all of this, it's worth me emphasizing that AI regulation, so regulation rather than the things like the ethicality and the process around implementation, are reserved. So Scotland has limits to how much we can dictate the rules around how AI is used, and some of that is dictated at a UK level. For now, the UK approach to regulation devolves that to individual regulators. So where there are Scottish-specific regulators, like SEPA, we might expect to see them becoming the arbiters of what's appropriate use of AI. But that in itself raises a question around capacity, which until recently, UK government wasn't necessarily presenting the resources to kind of resolve. We've been lobbying them hard on that for the last couple of years, and we have now, with the UK's AI action plan that was launched in January, seen some stronger commitments around making sure that regulators, which would include Scottish regulators, are in a position to actually support developers of AI in making those powerful and applicable. What do we mean by trustworthy, ethical, and inclusive AI, which are the cornerstones of our AI strategy in Scotland? So by trustworthy, we mean that you can anticipate, as the people of Scotland, where AI is going to be applied and what data is going to be used with it. By ethical, we mean that it's been designed in a way that considers what the people of Scotland think is right. And by inclusive, we mean that includes all the people of Scotland, regardless of their culture or their community. And to help you understand how we're hoping to put that into practice, we have a commercial challenge in train at the moment to develop technologies to help with public participation precisely around this. Obviously, there's a lot of ambition to use AI in those solutions, although always with a human in the loop, always as part of a human and AI team, to help make us able to use better participation methods that get more views from more people and get their informed and reflected views rather than simply their knee-jerk reaction to things. Now, I'm not saying that that means we need to do public participation on every single potential application of AI in practice, but it does mean we're hoping to have the realistic prospect of getting more than just the tabloid or knee-jerk reaction of the public when we start to take something that's been demonstrated in research and turn it into a tool that will be used actively in public decision-making about how to deal with particular public challenges, like those that Epic tries to address. That's everything from me for now. So I think we're going over to a Q&A.
Any questions? I have a question, but I will let you go first. If not, I will go with my question. Great, thank you. Yeah, I'm asking if there's any questions, and if there's not one immediately, I already have a question. Okay, I'll go with my question. Would you, actually, maybe I'll have this. Would you like to say a bit more about the AI register? So what I would like to know is what kinds of models might be on there, and very specifically, will it be possible to kind of search what models are on there, and will you be using something like a concept of a model card to describe what model is on there and what data is going into the model and what might the outputs be?
Sure. So the AI register, this is going to be a recurring theme, is something we built through the CIFTEC scheme, through the commercial challenge mechanism that we can use in Scottish Government. It was built by a Finnish startup which has now formed a partnership with Microsoft, so that it's very likely that their processes will be the ones used for the quality assurance of applications of AI throughout the sort of Microsoft world around Azure. So there's real critical mass, I guess, we're seeing around the particular processes that are being put in place there. In terms of what we mean by AI, to set the limits on what will appear in the AI register, we're taking the OECD definition there.
Which is?
Not something I can give you off the top of my head. Or certainly not something I'd want to try and give authoritatively off the top of my head.
So I guess for us at Epic, because we do develop models, eventually would you like our models on your register?
If they are being used as part of public services, yes.
Thank you. So our models would be trying to perhaps predict the risk or maybe even predict the disease on certain farms. And to do that, we would perhaps use some more sensitive data. Would you like to comment upon the use of that kind of data and then maybe the reporting of it into the model register?
Sure, and I think that's a good, hopefully tangible use case for everyone here. There are, of course, lots of administrative data sets held around agriculture, which I could imagine give really valuable information in understanding potential epidemiological outcomes. For example, knowing which bits of land correspond to which farms and which sheds the animals will be sort of grouped together in at the end of a day. So that kind of administrative data, much like all of the other administrative data I was talking about in the first part of my session, is limited in how much it can be shared by issues like quality and metadata and the process itself of agreeing sharing of the data. And that's all places where some of the innovations around data management that I alluded to earlier on will hopefully increasingly make it easier to combine that data and a fresh live version of that data with data sets for research purposes, whether in the Scottish safe havens for primary research or whether in operational systems for decision making at the end of the day. And once maybe those risk scores are proven, to put them in the field for live decision making or in front of ministers for hard decisions around stopping outbreaks. The other point to mention here is the potential, as that data becomes more available and better, more accessible, to augment it with other sources, things like satellite imagery, which hold the promise, which we've tested to various extents, of better monitoring agricultural land, so that when combined then with the administrative data, we have the two perspectives from the ground up and from the sort of objective top down to combine and give us the best possible understanding of the situation on the ground for combination with other data sets. And then ultimately, we would want to see whatever those models were developed for, developed through the research, to feed into public decision making, clearly articulated in the AI register. I say clearly, perhaps at a level of detail that would be a bit higher than in your average research output, and therefore accessible to the general public, but with enough specific detail, just enough specific detail to help make sure that we might feel the public have been fully informed about how data, which is ultimately theirs, is being used, but also about how the limitations of the modelling might affect the decisions being made for their benefit.
Thank you. Another question?
Hi, Sheila Vose, Scottish Government Chief Vet. I was interested to hear you say that it's a human-AI partnership. So often people think that AI is the future without that human interface. How do we get the message across to them that this is to augment, not to replace?
Through taking advantage of opportunities like this to talk to key audiences and try and get that point across is the approach we're having to take. Perversely, we in Scottish Government don't necessarily have the same platform that certain figures in the tech world have to give a very different narrative about the sort of the future of AI. But through the Scottish AI Alliance, as well as through our ministers and the opportunities they've had to speak about AI publicly, that is a message we've been consistently reinforcing. And I guess perhaps I'd ask everyone here to take that message away with them and share it with people they interact with.
Thank you very much, Adam Kleczkowski, University of Strathclyde. Thank you very much for a very interesting talk. I just wanted to come back to the data, and particularly like in epidemiology, a lot of data are not publicly available, and therefore they're not available to the LLMs. I mean, is that, so there is a possibility of working with closed data, so training LLMs on sort of ring-fenced data. How do you see that happening and whether you've encountered things like this in a work, particularly in a government-related work?
It's a really interesting and valuable question. I think so far we've not seen much applied use of fine-tuning, which is to say retraining of models on specific data sets to I guess, introduce sensitive information or otherwise. So far, a lot of the applications across government in the UK have been through prompting, which is to say not changing the underlying AI model, but giving it some extra information as part of the prompt. Anyone who's used ChatGPT or some other of these Gen AI tools will know that you generally give it a bit of text to describe what you want from it. Now, there are limits to how much text you can put in there, but they're quite expansive. So you can often shape the behavior quite a lot by putting in contextual information alongside the specific request you're making. And that tends to be how a lot of applications of AI, both within government and a lot of the proposed commercial applications, have been working so far. What limits the use of fine-tuning, which is to say changing the underlying AI model, is the sheer expense of computing power needed to process that extra data and change the weights of these very, very expansive models. So, you know, the latest generations of large language models have numbers of parameters, if that means anything, of an order of magnitude of hundreds of billions. It's worth pointing out that that's still a couple of orders of magnitude less in information content than the synapses and the, I guess, internal nonlinearities of our neurons. So even those biggest large language models have a lower information content than a human brain, than just an average human brain, which both makes it incredible that they can do what they can do, but also should help you recognize that there must be limits to what they can do compared to a human brain. But I digress. The crucial point here is that is still a huge volume of information to be tweaking if you're retraining one of these models, if you're fine-tuning it. Now, for those who've been following AI news, you may be aware of DeepSeek, which was developed by a Chinese startup recently, which, although it was only matching the performance of the sort of the biggest and highest value large language models coming out of some of the big American companies, was notable for doing that with much lower cost on much lower performance hardware. Part of how it did that was to take those big, very intricate large language models and boil them down, technically what's called distilling, into much smaller, more compact models for specific purposes, and then stringing those together with some logic that directed, based on the task being given, to the right model for the job. Now, as it happens, there are examples of companies in Scotland, companies which have attracted large amounts of funding and international recognition through things like the Alexa Prize, which are specialists in precisely that distillation process. So this is technology which is far from being out of the reach of us here in Scotland. You know, this is technology we can realistically expect to deploy. And our data scientists within Scottish Government have been experimenting with fine-tuning of distilled models, which I think is the kind of path we'd want to be taking in order to take sensitive corpus of data, for example, epidemiological, and then maybe take a distilled version of a large language model which had been focused in on epidemiology, on medicine, and then to sort of set that a task there. I mean, I'd add that whether that would be useful will come down to the use case and whether large language models or generative AI are the best tool for that job. I would imagine for a lot of the problems we might face in epidemiology, that you'd want something a bit more bespoke down the lines of AlphaFold to do something particularly useful. But it would just depend on what you're after. And I did give some examples of where, even in disease research, LLMs have apparently been showing the capability to do things that a person can't. So that's not to deny the potential benefit of large language models in epidemiology.
Thank you very much, Roger Humphrey, SRUC. There must be a potential for AI to produce what the internet might perceive as being data, and therefore a feedback loop. And I just wonder if there are mechanisms already in place to try and prevent that happening, so that we're making use of seminal data rather than reinforcing a particular route of understanding which may not be correct.
It's a great question, and I mean, I think it's something that has been widely speculated that one of the reasons that we might not see the exponential improvement in performance, which has been suggested by some people around AI, is that we're now constantly polluting the data that exists out there on the internet with synthetic data generated by generative AI. In general, although there are ways that you can purposefully watermark things coming out of generative AI to try and keep track of what is synthetic and what isn't, there's no guarantees that those will be applied generally, and there's no fundamental way to know whether data has been produced by generative AI or not. There might be various ways to check whether it could have been, because it replicates the kind of patterns that we know that particular Gen AI model has found in the data at large. But yeah, there's no technical solution to know whether data has decisively come from a generative AI tool. So I think that is a real concern, that the biases that already exist in those models might get exaggerated over time by retraining with more of the same data.
So Ian McKendrick, BIOS. Thank you, Tom. It's really interesting. You touched on ethics at various points, though I think talking about the ethics of what goes in, who owns what goes in, and also you talked about trust by the public and what comes out. So a few years ago, some of us in EPIC worked on the ethics around mathematical modelling, and the kind of the concept that actually there were unethical behaviours could be implemented around models, and actually not just unethical uses, but actually it's possible to have an unethical model for a particular purpose. And we published that, and to say it was met with a certain degree of negativity by the modelling community is probably fair. But this is clearly something that's even more relevant and salient to AI. So again, where do we go with this? How do we actually maintain how do we ensure that AIs are themselves intrinsically ethical and encourage people to then use them in an ethical way?
And I think key tools in that argument will be things like the AI register, where there's an expectation that before an AI tool goes into general use, there is a public record of it that guarantees it's gone through a certain process, which might involve checks for algorithmic biases, flaws in the design of the model that might lead to introducing new biases that weren't even in the data, or exaggerating biases that were in the data, or indeed making sure that the data that's been used to train the model was suitably unbiased in the first place, or advertises the biases that it contained very clearly to anyone who's using the outputs of the model. So I think that transparency is key. as well as processes like the one I described of regular participation with the public in an informed and deliberative way to understand their views of the acceptability of the risks that might come along with a particular model, with the biases that pertain to it.
Any more questions? Any more questions? Any more questions? Or would you like to continue the... Am I allowed to now? Yes, yes, sure.
Thank you. Stepping back a bit, obviously there's been a huge progress in LLMs, AI, machine learning, and so on. But there's also a huge hype associated with that. And there's a danger that if something goes wrong somewhere, then there will be a backlash against that. I mean, what are your views on, can we prepare for that? Can we ensure that, well, we probably cannot ensure that it will not go wrong, but how can we smooth that out?
I think it's a really good question, and another real risk that we need to confront. As I understand it, Gartner, anyone who knows it, is a company that specializes in sort of trying to give a representation of the general mood of industry on particular topics, and is particularly famous for its hype curve, which is a particular sort of function that describes the level of hype around a particular technology over time. They seem now to be consistently describing AI as descending down into the pit of despair in that curve, which technologies like blockchain and crypto are currently in, and may emerge from again to a more muted but useful sort of level of public excitement in the future. And I think the real danger here is that as the overpromising around generative AI in particular dips into that well of frustration, that it brings AI more generally along with it, and that despite those incredible uses of deep learning that we've seen, we'll see a drop-off in funding and support for the application of AI more generally as that disillusionment comes in. And I think the mitigation of that is helping funders, senior decision makers, at least to understand that possibility and the need to protect the general AI brand from whatever happens to the Gen AI brand over the coming months and years. And that's what we've been endeavouring to do within Scottish Government. But for the public at large, again, we can't compete with some of the other voices out there that will tell different stories for different reasons. And so, to my mind, that's the most we can do in terms of trying to mitigate that sort of collapse in public confidence in AI in the future.
Because we see it with our own eyes, the collapse of the epidemiology, human epidemiology in the US, where you see the funding being withdrawn from NIH, and that's a sort of COVID. It's a wave following COVID, and perhaps some of the overhyping of the predictions based on that. Anyway, yeah.
It's a valid point, and the frustration for me, I guess, is that Gartner are quick to use the hype curve, but not to sort of communicate that greater lesson that no one should be following what everyone is excited about in the private sector, and instead everyone should be trying to take a longer and more balanced view of things rather than rushing to follow the herd on whatever the most exciting new technology is. Obviously, in the case of COVID, the extra investment funding during the crisis itself was probably very necessary and hopefully mostly well used.
Any other questions?
How are we doing for time?
I was very pleased when you said that you could perhaps use these AI models to augment what the scientists were doing already. Would you like to expand a little on that? Because I think actually we're quite excited to use new tools.
Yeah, absolutely. And Sam and I were riffing on this before I got talking. I don't have any epidemiology experience, but I do have some practical experience of applying network contagion models from an information and sort of memes perspective, well, a sort of practical knowledge perspective, from an organizational design use cases and network economics. So I feel I have an awareness of some epidemiological tools, and for those, I see some parallels to the kind of protein folding material science applications where there seems to have been demonstrated research value from deep neural networks that have been carefully engineered for specific tasks in those areas. So I guess in particular, we often have reasonable models of dynamics of contagion at a very local level. But then as we get up to large networks, we can sometimes establish results around topological features that will tell us something about the way that propagation will happen across that network. But the multiplicity of different networks we might look at stops us from finding all of the relevant topological features by brute force. Now, I do wonder whether there's opportunities there, for example, to use methods like those used for protein folding or material science to try and identify some of those descriptive features of the network that would predict particular contagion dynamics once you get away from sort of some of the canonical network structures, which might help, for example, as better administrative data tells us more about the practical contagion networks we might see in Scotland or elsewhere, to quickly draw from that some idea of what the contagion dynamics might look like. Obviously, computer modeling may be a perfectly reasonable tool given the scales of networks we're talking about in practice there, especially given the concentration of farms that Christos showed us earlier. But yeah, that's kind of one avenue. And then just in general, I mean, what we have seen, and I'll emphasize there, that approach that DeepMind took to protein folding was a very, very long way away from the promise of Gen AI, where you just get it to do the job for you. Humans spent a very long time with expert knowledge about how to model protein folding to design a system that could bring deep learning effectively into that. So it's not a trivial step to do that. But we have seen examples of LLMs seemingly help the research process itself. As I was saying before, I intuitively try to think of it as interpolating between stuff that appears a lot in different literatures, but which no one is well read enough to sort of link up. And I think there are potentially real possibilities there. And as I understand it, a lot of researchers I've spoken to in various fields, quantum, genetics, are often using large language models alongside their research. I myself have had technical exchanges with them. You can never trust what they're telling you entirely, but it feels useful to be bouncing ideas around with them, and they can often be the starting point for exploring hard research or Wikipedia to get something that is a bit more reliable. So that kind of co-researcher model, I'd expect to be one that's really valuable going forwards. And we're seeing, so Google has been specifically developing, I think they call it a co-scientist tool. And one of the positive examples I didn't get into in depth during my presentation but was reported on recently, was from some of the testing of that tool, which supposedly, anecdotally, demonstrated the tool helping come up with a number of hypotheses, which included the latest hypothesis from a particular research team, as well as some pretty convincing alternatives as well. Now, I guess time will tell just how useful that is, and whether, without the foreknowledge of which one of those the researchers had already come up with, that would just be a multiplicity of different hypotheses that you wouldn't be able to sort of usefully to unpick, or whether that's fast-tracking the hypothesis generation role that people play in research. Only time will tell there. And despite my heuristic about fast and slow thinking, I would struggle to tell you how much fast thinking and how much slow thinking goes on when scientists are generating hypotheses in the first place.
Thank you. Last question? Or
so just in terms of sustainability, because you haven't mentioned it, a lot of things that these companies do, regardless of how expensive the carbon footprint of an average user, for instance, using Gen AI, information that you can get, let's say Googling it, that people rather use ChatGPT, etc., is extremely expensive in that way. Is the government thinking about limiting the use of these tools? Because the price is going to be lots of energy, and there are places already that are struggling with water supply. I really think governments have to get in and intervene, because there is no other way. Because so I just want to say that first they invent these amazing tools and put it, promoting so users get access to it, and then they guilt us for using it. So I think that there is a lot of work in there.
I think it's a really valuable and reasonable concern, and I'm remiss for not mentioning the environmental aspect for ethics. It's complex because a lot of the advocates for AI will argue that AI tools may help with solutions for some of the environmental issues we face. At the same time, Scotland has a green data centre strategy and has both a lot of renewable energy compared to most countries and a lot of water compared to most countries. So there's the possibility, by shifting some of those AI workloads to countries like Scotland, that the overall global environmental impact might be reduced, particularly as Scotland continues to bring more green energy online and move towards a place where using some of that green energy for AI won't be driving people to use non-renewable sources for domestic needs. And then I think the other thing to consider in the environmental discussion is what we saw with DeepSeek, and more efficient models starting to become relevant in terms of their performance compared to the big brute force models that have been the focus of attention for the last couple of years, is the prospect that, assuming the performance on benchmarks plateaus, we might expect to see the race shift increasingly towards doing it as affordably and economically as possible. I wouldn't necessarily expect to see the big brute force models go away, because they may still be the way that new data gets incorporated into the collective representation that's available within models, because of course those higher performance models have been built by reproducing what the big brute force models can do. So I don't see the brute force models going away, but a lot of the work could start to shift towards coming up with the most high-performing and, I guess, application-specific focused models. And that, too, should mean a shift in terms of the environmental implications. Obviously, the challenge for countries like Scotland with those green energy and water resources will be making sure that the way in which we do AI infrastructure recognises both of those roles and balances off those environmental implications against the potential benefits in general and specifically for things like environmental modelling. And I think the last consideration would be, as yet, I don't think any of the producers of those big brute force models have made any money out of them systematically. So you might expect economic pressures as well, ultimately, to certainly in terms of use of energy, force a move towards more energy efficient approaches to AI. Obviously, in terms of water, that's a question of water resource management, which I think is already a problem for lots of countries independent of AI.